Hey everybody, this video is going to be about graphing a line if you're given 2 points. So let's say that we're given 2 points, A and B. So I just picked some random numbers here, small numbers, so they shouldn't be too difficult. And we're going to see what to do. So as always, the first thing we do is we start out with our equation, y equals mx plus b. And then we just insert what we have, like always. So just like last time, we remember that that's an x and a y, that's an x and a y, and we put those in there, but wait a second, we only have a y and an x, but we don't have an m given to us like the last type of question, nor do we have a b. So we have to figure out what to do. And by the way, I could either set it up like, I'm thinking 3 equals m2 plus b, that would be like point A, or if it was point B, y equals mx plus b would look like 7 equals m times negative 1, well this would be a bracket, plus b. So this one would correspond to point B. But the problem is, like I said, I have 2 unknown values, and when we have 2 unknown values, we actually can't solve our thing. We can only solve for an unknown value if we only have one unknown value to solve for. So what that means is we have to either figure out B or figure out M. Now, which one should it be? Well, let me see here. I'm just going to make some space. Do we figure out B or do we figure out M? So I know I have 2 points. 2, 3 would be like 1, 2, 1, 2, 3, somewhere over there. Negative 1, 7 would be like over here somewhere, whatever, something like that. And then it would cross. So let's intuitively think for this for a second. Do we know the exact spot that exactly crosses? No, we don't. So we don't know B. But do we know the exact dots? Of course we do, because we're given 2 points. Okay, but what do we get from 2 points? We get a line segment, and a line segment has a measurable slope, like meaning we could measure the little staircase that is built in order to make this line. We could measure this actually, so because we do know the points exactly, but we don't know B, we do know the points, that means we can measure this slope, and then we'll have our M in order to do our equation. And that's what I'm going to show you how to do, is how do we find M? So I'm going to use these 2 dots, right? Remember I had the 2 dots? And what I'm going to do is try to find the difference between the 2 of them, okay? Now, difference is a word that reminds us of subtraction. Like if I said, what's the difference between $10 and $1, you would say it's $9, right? Because $9 is the difference between 10 and 1, but we also know that $9, you get that by saying minus. So when we think of the difference, we have to think of the word minus. Okay, so what does that tell us then? We just have to take one of these points and subtract it from the other. So let's try doing this. Let's do A minus B. So there's my coordinates for A, and there's my coordinates for B. So I'm going to subtract them, and here's my thoughts, of course. So I have 2 subtract negative 1. That's like saying 2 plus 1, so 3. So that's a 3. Similarly, no, I'll just do it over here. 3 subtract positive 7. That's like saying 3 minus 7, which is like saying negative 4. So negative 4. And what did I do here? I measured the difference between the x values. So I'm going to just note that. That's the difference between the x values. And here I measure the difference between the y values. Difference between the y values. Okay? This here is not a dot. Huge, huge. This thing here is not a new dot. So far, there's only 2 dots. They are this and this. This stuff represents a difference Now a difference in any theory means you're here and then you're in a different spot later. There, boom. What happened? There was a distance traveled. And I want you to think about that. Anytime you have this thing here, when you get your conclusions, this represents distance traveled. That's what it represents, okay? 3 and negative 4. All right, I'm going to erase some of this stuff. So there's our distance traveled. Now, if we think about slope, we know slope equals m, and that's rise over run. Now, rise is distance traveled up and down. Well, what axis is that? That's the y-axis. So the y points, there you go. The rise here will correspond to this number. So the rise will be negative 4. And the distance traveled with the run is left and right. So that's the x-axis. So we'll use the x points. 2 minus negative 1 makes positive 3. So there we have our slope. Our slope, m, equals rise over run, equals negative 4 over negative 3. And of course, negative 4 over 3 could be written like this, but this doesn't help us because we don't know where the negative sign goes. But we could also write it like this. So as we're doing this, we know we could have a slope we can use like this, or a slope we can use like this. In this case, this is down and right. And in this one, we're going up and left. Okay, down and right, up and left, up and left. It's the same thing, all right? So that is how you find your slope. Okay, now I know I get this question, how did you know to use a minus b? Like, what about the other way? What about the other way? Well, let's try it out. So first of all, we know that slope is 4 over 3 negative, okay? So I'm just going to see if we can find that again. Okay, let's try it with this one instead. I guess I could have left that there. Let's see what would happen if we did b minus a. Maybe it makes a difference, maybe it doesn't. So b is negative 1, 7, and a is 2, 3. Okay, so in our thought cloud, we're subtracting them. So negative 1 subtract 2, that makes negative 3. And then over here, 7 subtract 3 makes positive 4. So there's positive 4. We know that this here is the change in x, and we know that this here is the change in y. Okay, now some teachers will use the symbol delta. Don't worry about that if you're like, what? Change in x, change in y. Okay, just like here, this was a change in x, change in y. So if this was a slope, remember that's distance traveled. Slope is the rise over the run. And the rise over the run, that means the change in the y-axis thing. So that's the y point, 4 over negative 3. This is the change in the x value, so I would be running side to side again. So 4 over 3. 4 over negative 3. And does that match with this? Yes, it sure does. We are back at that situation where we have to understand that negative 4 over 3 is the same as 4 over negative 3. So it works either way. You can either choose to go A, take away B, like this, or you can say B, take away A. It really doesn't matter. What you'll do is you'll get your slope. Okay, so with the slope, now that we have the slope, we can go back to the previous video stuff. And the previous video stuff says we always start with the equation y equals mx plus b. There's our points before. So now all we have to do is pick one of these points. We can pick b, or we can pick a and put the x and the y value in. So, maybe I'll use a first. So y is here, y is 3 and x is 2. And m is negative 4 over 3. And then we don't have b, so that would be multiplied. And then you just go through it like before. If I use b, I end up with y is 7, slope is negative 4 over 3, and then x is negative 1 plus b. Okay, so here I've used the coordinates from the point from A. There's my x and y from coordinate A. And here I've used my x and y from coordinate B. All right, so I could use this way, or you could use this way, whichever way you want. Usually people use the points that, the point that has easier numbers. Like sometimes people don't like using negative numbers, so they just would go to A automatically. Either one of them is just fine. And once you have that, you can continue to find B like the previous video. So I'm just going to continue using point A just for the sake of time and space. I'm going to try and find B now. So I'm going to solve that there. Negative 4 times 2 is negative 8. 3 times 1 is 3. And that equals 3 equals B. I want to get rid of this guy. I'm going really quickly now because you've seen this so much before in the other videos. So I'm doing that to both sides. And then I'm just going to bring it down. 3 plus 8 over 3 equals 0 plus b. Now, of course, we don't have to show the 0. And this is a 3 over 1. Now, 3 over 1, I have to get a common denominator of 3. So I know I can triple both items here and get a 9 over 3. Okay, so I'm just going to adjust that down here right now. 9 over 3. And then 9 plus 8 makes 17. So I'll have 17 over 3 equals b. Sorry, it's so small. 17 over 3 equals b. That's what we have for b. And of course, what do we do after that? You put that through the division machine, and you get 5 and 2/3. 5 and 2 over 3 equals b. Okay, so now we finish it off by saying, what's our actual equation then? Well, y equals mx plus b. And now we leave the y and the x blank. We leave them as the letters. And instead, we just put in our m and our b. And there's the equation. And once you have this equation, you can go through and solve a graph in any way that you want. You could make a table of values, or you could use the y-intercept thing or whatever. I'm going to show you a few ways right now. Let me just get this written up here. Y equals negative 4 over 3 x plus 5 and 2/3. So now we're going to graph this bad guy. So the first way to graph is the table of values. And I'm not going to show that because it takes too long, but you know how to do that from previous videos. You can always do that if you're not sure what else to do. The second way is using the y-intercept. So what do we know from this? This here, that's the y-intercept. And that means there's a point that is neither left nor right from the y-axis. It's exactly on the line of the y-axis, exactly on the line. But it is exactly at a height of 5 and 2/3, whatever that is. So if I'm going to do that, what I'll do is I'll create my line here. Assume that's straight, and I'll just tilt this thing a bit there. No, I'm just kidding. Let me clean that up a bit. That's not much better. Okay, so 0 and 5 and 2/3. So I'm going to just make a dot right about there. That's 5 and 2/3 in height. And that's a for sure dot. It's not just a tick mark, it's a dot. And I totally estimated the distance from here to here. I didn't measure. So I'm going to make a little lightning bolt. That lightning bolt says, look, I didn't measure anything. So now I know nothing can go through this area. Okay? Nothing goes through that area. And now I'm going to look at my slope. So slope is negative 4 over 3 or 4 over negative 3. Which slope do I use? Well, it's the same slope, but which depiction do I use? I can't go down through this, and this would be down and right. and this would be up and left. So I can't go down because I'm going to go through my no man's land, so I'm not going to use that way. I'm going to use this way. Rise of 4, run by 3. Rise of 4, run by -3, sorry. So I'm going to make 2 more dots, tick, tick, that's it. Now to rise by 4 is just simply to go to 9 2/3 and to 13 2/3. That's rising by 4, rising by 4. Now those are not dots, they're just tick marks. I'm just measuring how far to go on my graph. And then I see I have to go to the left by 3, so there we go, -3, -6. All right, so there's my original dot. I'm going to rise by 4, go to the left by 3. Going to rise by 4, go to the left by 3. See, it matches up there. Make my next 2 dots, and then there's your last step. You just do a little bit of that, and there you go. Now, there's no room for me to put the name of my graph. So maybe for this particular case, I'm just going to say down here, name of line is y equals -4 over 3x, -4 over 3x plus 5 and 2/3. There. I'll just maybe put that, and maybe up the side I'll put an arrow. You know, I did that down here because it's just too clustered up over here, you know, because I only gave myself a little bit of room to make my thing. So last check, is this okay? So I estimated this, then I made my lightning bolt, check, and then I colored that in. And then I examined my slope, and I said I have to go up so I don't go through this. Tick mark, yes. And then tick mark to the left, good. Arrow tip, arrow tip, arrow tip, arrow tip, arrow tip, arrow tip, that's good. And then I labeled it, that is good. All of those things are necessary on that, okay? So that's nothing more than the previous video kind of stuff. We can use the y-intercept. The other way is to just use any point. So I think one of our points was 2, 3, right? And then B was -1, 7, I hope. Okay, so we have, I could use this point here. I'll do A, okay? I could go 1, 2, 1, 2, 3. And there's point A. And then if I have to go down by 4 and to the right by 3, I could do that. 1, 2, 3, 4. 1, 2, 3. So down by 4, 1, 2, 3, 4, and to the right by 3, 1, 2, 3. There's my next point. I could extend this graph and go even further. Down by 4, 1, 2, 3, 4. And to the right by 3, 1, 2, 3. So there we go, down, 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 down by 4, and 1, 2, 3. There's my next dot. And so there, I could make my line like that. That's supposed to be on the dot, by the way. I could make it like this. -5, 3. Just got to make the little notes on here. 1, 2, 3, 4, 5, 6, 7, 8. Maybe I'll just put an 8 there to indicate that each of those is 1. There. This is also perfectly acceptable. Oh, this last one I forgot to put my little y and my little x. Okay. So here, there's my my y-axis, and then my x, and then there's my line. So, and the equation. So this here, it examines a different portion of the graph line. Like here, we're way up here. This one, we're way down here somewhere, okay? So that's using point A. Now, if you can believe it, we can do the same thing with point B. Point B is -1, 7. 1, 1, 2, 3, 4, 5, 6, 7. So there's a dot right there. Let's call it B. We know that slope is -4 over 3. There's enough room for us to do that right here. 1, 2, 3, 4 down, and 1, 2, 3. 1, 2, 3, 4 down, so -1, and 1, 2, 3. Whoops. So there again, we have our dots. Da 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 da, ba 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 ba, y, x, and the equation name. So again, this, if you can believe it, is just like using It's the same graph, sorry, it's the same information graphed, but it looks different than this one or when we did it with point A. But this is also perfectly correct. So that's a third and a fourth way. The last way here is to plot both points and just connect the dots. I like this way the best. 1, 2, 3, and I can stretch that out a bit more. Okay, how about like this? -1, 0, 1, 2, 3. Okay, so 0.2 and 3. 1, 2, 3, 4, 5, 6, 7. I have to go as high as 7. So A is 1, 2, 1, 2, 3. There's point A. And then B is -1, 7. So there I've made my point A and my point B. And then all I have to do is connect those two dots. Now notice, because I actually measured this, there's no need for a lightning bolt. There's no need for a lightning bolt down here either. So I actually plotted both dots just easy as I could. -1, 1, 2. I plotted both dots, connected the dots, made my line, arrow tips, arrow tips, arrow tips, y, x, and then the equation name. And this also is the same as graphing it from this and building stairs, this and building stairs, or using the y-intercept in building stairs, or using the table of values. So technically there's 5 ways that you can graph this thing, if you can believe it. So definitely go back, hit pause, rewind, watch again, and ask me if you need some clarification on this. But this, just really soak this in. You guys could be masters of this in no time.